Modeling systems of equations algebraically. Example 1. On December 13th, 2017, the Houston Rockets played the Charlotte Hornets. The Rockets won 108-96. James Harden had 21 of the 108 points. ESPN stats said he made 9 baskets, but the statisticians did not say just how many 3-pointers and 2-pointers that he made. We should help. A. Write a system of equations to represent this situation. B. Algebraically, determine the number of 2-pointers and 3-pointers Harden had by solving the system of equations. C. Interpret your solution in the context of this problem. Part A. We are going to write a system of equations to represent this situation. The first thing we want to do is identify our variables. What are the 2 things we are talking about in this problem? We are trying to figure out how many 3-pointers and how many 2-pointers he made in the game. So we are going to let x equal the number of 2-pointers and y equal the number of 3-pointers. Now, let's identify the 2 equations that we need to write. It looks like we're going to have one equation that's talking about the number of points that he earns, and another equation talking about the number of baskets he makes. Let's think about the number of points that he is earning. We know that he scored a total of 21 points that night. Thinking about the number of points that you can score in a basketball game. Depending on where you shoot the ball, your shots are worth either 2 points or 3 points. So we are going to multiply 2 times the number of 2-point shots we took and combine that with 3 times the number of 3-point shots that we took. And we know that James Harden scored a total of 21 points in that game. Now let's think about the number of baskets that he made. So we're going to combine the number of 2-point shots that he took plus the number of 3-point shots that he took. And we have a total of 9 baskets that he made in the game. Part B. Algebraically, determine the number of 2-pointers and 3-pointers Harden had by solving the system of equations. The first thing we want to do is check to see if we already have a pair of inverses, a positive and a negative of the same term. Looking at this system, 2x, 1x, 3y, and y, we do not have a pair of inverses. So we're going to multiply to create a pair of inverses. I'm choosing to multiply the bottom equation by -2. Let's go ahead and rewrite our system of equations. The top equation stays exactly the same, but the bottom equation changes now. I need to distribute this -2 to every term in this equation. This results in -2x minus 2y equals -18. And when we add the equations together, the positive 2x and the negative 2x cancel each other out. When we combine the like terms of the y's, 3y minus 2y leaves us with 1y. When we subtract 21 minus 18, it leaves us with 3. Or we can write it as y equals 3. And we have just solved for our very first variable using the elimination method. Now that we know what the y value is, we're going to use this, plug it back in to one of our original equations to help us figure out what x is. It doesn't matter which of the original equations you choose. I'm going to pick the one on the bottom. X plus y equals 9. X plus 3 equals 9. And this is a one-step equation that we know how to solve. Subtract 3 from both sides of the equation, and this leaves us with x equals 6. And we have just used the elimination method to solve for both of our variables. Part C. Interpret your solution in the context of this problem. We just said that x equals 6 and y equals 3. But what do these values really mean? Going back to where we set up our variables, we said that x represents the number of 2-pointers that James Harden took in the game, and y represents the number of 3-pointers that James Harden took in the game. So when we have our final values of 6, then we can say James Harden took 6 2-point shots in the game. And the y value of 3 tells us that James Harden took 3 3-pointer shots in the game. And lastly, we are just going to take a second and check to make sure that our solutions work for our system of equations. So, looking at our original system of equations, the first thing that we're going to do is substitute in the values of x and y. We replace all the x's in the system with 6's and all the y's with 3's. Then we evaluate each term. We want to know if the top equation actually equals 21 and if the bottom equation actually equals 9. And it's true. These values make both systems of equations true. So, we did it correct. Good job.